This is the lesson on the Pythagorean Theorem, Chapter 7, Section 3. And so the Pythagorean Theorem gets its name from a gentleman whose name was Pythagoras. He was alive about 2,500 years ago, and he was living in Greece. And he came up with a school, and so he's probably a pretty well-to-do guy. Got a bunch of students together, and they found out certain different things about mathematical operations, numbers, and so also geometry. And so what he found out was something about right triangles in this theorem. And here's how it came about. And so just a possible way he might have figured it out, or his students figured it out, was to take a square. And so this square here is the same as this square over here, this large square. It's 6 spaces, 1, 2, 3, 4, 5, 6. So this is a 6 by 6 square. This is also a 6 by 6 square. So we see that these two squares are exactly the same. So the area of the first square, so we'll say square 1, and I'm talking about the large square here, it has an area equals 36 units squared. And so square 2 also has that same exact area. It has an area of 36 units squared, just multiplied 6 times 6. Well, I noticed something about this. Look at these white shapes in here. These are triangles, and they are all the same. 2 by 4, 2 by 4, 2 by 4, 2 by 4. So we have to remember that the formula for a triangle is half the area, or half the rectangle that it would complete. And so base times height, so the 2 by 4 divided by 2. So this is the large square here, and if we go ahead and take out these smaller squares, so the area of those smaller triangles is this. We've got area equals 1/2 times by 4 by 2. So that area is going to end up being 8, and times by 1/2 makes 4 units squared. And so each of these has an area of 4. That's the area for each of those. And so these also are the same size triangle. They also have areas of 4. And so notice that we are going to take away, those areas. And if I go ahead and take the 4 triangles and multiply it by the 4 units squared, that gives me 16 units squared. And if I go ahead and subtract it, and since it's the same on both, we see that that ends up giving us 20 units squared. And we also have 20 units squared on this side. Well, what's left over? What makes 20 units squared? Well, what makes it is c squared. That's what that is. So I can't really figure out what c squared is the way it's angled like that. But I do see that if I took out those triangles, that's what I get. So c squared equals 20 units squared. And on the other side, what equals 20 units squared? Well, it's the b squared and the a squared combined. So combined means you have to add them together. So I see a squared plus b squared equals 20 squared. Well, c squared also equals 20 squared. So that means that a squared plus b squared would equal c squared. And that's the Pythagorean theorem. That's what we're looking for. So how does it relate to the triangle? Well, let's take a look. So this square b, it was found out, the area of it is, well, it's b times b. In this case, I can see that it's 4 units by 4 units, so I know this makes 16 units squared. This side right here is a by a, so it's a right there, and that's what this a represents here. That's the side length. And I know it is 2 by 2, so that makes 4. And 4 and 16 definitely do add to make 20. This one I can't tell because it's at the angle. And so its side length is c. So basically, if we take the square of the two sides that are connected by the right angle symbol and set that equal to the one that's the longest side, we could end up finding one of those missing sides. So we have a little bit more terminology here. The longest side of a right triangle is called the hypotenuse. And so we've got the hypotenuse. These two sides, the two sides connected by the right angle symbol, those are called the legs of the right triangle. And so we're going to use those to help us solve for missing sides. So let's take a look at some problems here. So this only works with right angles, or right angle triangles. And so we have to look for the longest side. The longest side is always opposite the right angle, and that's going to end up being our hypotenuse. The two sides connected by the right angle symbol are the legs. And so the legs are the a squared plus b squared portion. The hypotenuse is equals the c squared. So it doesn't matter which one's a and which one's b. You just start substituting the numbers in that are connected by the right angle symbol. So 21 squared plus 20 squared equals c squared. So we do some work. 441 plus 400, that's what we get when we square these two numbers. And this all equals c squared. Well, we go ahead and add those two together. We get 841 equals c squared. And then we've got to take the square root. Taking the square root cancels out the squared symbol. Do the same thing to the other side, and we'll have our answer. So it just so happens that square root of 841 is 29 equals c. Oops, not c squared anymore. Get rid of that squared symbol, equals c. And so what are the units? Well, right up here, kilometers this time. So 29 kilometers would be our answer. Looking at this one, the two sides connected by the right angle symbol, those are the legs. The side opposite, that's the hypotenuse. And so we're ready to go ahead and set up our equation. We got a squared plus b squared equals c squared. That's our formula. So we got 7 2/10 squared, and then plus the 9 6/10 squared equals the longest side, the hypotenuse squared. So 7 2/10 squared equals 51 84/100. 9.6, 9 6/10. When I square that, I get 92 16/100. And this all equals c squared. Well, collecting these two terms together gives us a perfect square of 144. And so we're ready to take the square root of both sides. And so that gives us our answer. So we get 12 is the value of c. Looking back here, I see that the units are feet. So let's make sure we write in 12 feet. So on this one, we've got a right angle symbol right here, and that tells us that these are the legs of the right angle of the triangle, and this is our hypotenuse. The side opposite the right angle symbol is always our hypotenuse. So 5, or we'll start off with our formula, a squared plus b squared equals c squared. So we've got 5 6/10 squared plus a squared equals 10 6/10 squared. So 5 6/10, that makes 31 36/100 plus a squared equals, and then 10 squared, well, that makes 112 36/100. So over on this one, we have to do a different operation because I need to solve for a, and a's on the left-hand side. I need to move that 31 36/100 over, so I need to subtract it from both sides, and I've got a squared now equals 81 when I do that subtraction. Well, I'm ready to take the square root. It'll cancel out the squared symbol, leaving me just with a. So a equals 9. And the units are inches. So we'll write 9 inches this time. Well, those are the problems you'll see on tonight's homework. Good luck.